lesson 4.3.2. In a way, continuing where we've left off with 4.3.1. More information here. Big thing we are working on today is reference angles. How reference angles can help us. And the idea is, so like if you glance at example 1, we're trying to find the 6 trig functions of 315 degrees. This is not a calculator thing. This is finding exact answers, which is a necessity in trig. But the idea of I can do this without picking up my calculator. And you guys know that chart you're supposed to be memorizing? The 30 degrees, 45 degrees, 60 degrees. Okay, so that chart is going to relate to all these reference angles here. That's what's going to happen, is we're going to be able to relate 315 degrees to one of those 3 angles and use the information on that chart and just look at what quadrant it is. So there's kind of 4 steps. You should have access to your chart. Figure out where it is so you can flip back and forth today, because you will need it.
Do we also need the unit circle?
You don't really have to have the unit circle right now. Okay, so there are 4 steps as we talk about this. And first step is figuring out the reference angle of the given angle. Remember reference angles, what I've told you? They're always on the
Same.
x-axis, right? And they are always, it's how far the angle is from the x-axis, I should say, right? So it's always less than 90. It's always positive. It's always between 0 and 90, positive, because it's how far an angle is from the x-axis. And so that's what we need to find first, is 315 degrees. How far is 315 degrees from the x-axis? So, and this is where I don't necessarily say I would encourage the unit circle right now. You've got to learn to think logically with the unit circle. 315 degrees. Can you figure out where that is in your brain without looking at the unit circle?
Mm-hmm. Yeah.
Because we know that this is 0, 90, 180, 270, 360, yes? So where does 315 have to be?
Yeah, between 270.
Yeah, in between 270 and 360. 315 is somewhere in there. So if I want to know how far this is from the x-axis, how am I going to figure out how far that is from the x-axis?
Subtract 360. Well, subtract 350.
Okay, so we're subtracting 360 and 315. If we were over here on the other end, we'd be using 180 and adding or subtracting. But we want to know that difference there. Did I get your question?
So are we just using that side of the x-axis instead of further away one because we're in that quadrant?
Yes, you want to use, so if you're in quadrant 4, you're using 360.
Okay.
If you're in quadrant 1, it's already between 0 and 90. If you're in quadrant 2 or quadrant 3, you're using 180 because you're using that closer portion of the x-axis. Okay? Okay, so reference angle, 360 minus 315 degrees is 45 degrees. Is that a familiar number?
Yes.
Hey, yeah, 45 degrees is one of our big 3, isn't it? Coincidence? Not really. Okay. Step 2, we've kind of already done. Figure out what quadrant the angle is in. Well, we've already talked about this, haven't we? What quadrant did we end up in? We ended up in quadrant 4, didn't we? And if you want to think about it, and I'm going to kind of, this is kind of what it's leading us to. It's over here in quadrant 4, right? Our reference angle is how far are we from the x-axis, which we were 45 degrees from the x-axis. And what did I teach yesterday? What did Jaden just ask about during question time? All students take calculus. So which quadrant does this fall in? Calculus, which is the cosine quadrant. So this is telling me my signs on my final answers. That's why we need to know what quadrant we're in. I mean, we kind of had to talk about what quadrant we are to get the reference angle, to get that 45 figured out. But this is going to tell me what signs we're going to get in the end. Okay. So, step 3 is to write out the answers to the trig functions based on the reference angle. So, I need your brain to think 45 degrees. And why are we thinking 45 degrees?
Because it's in our chart.
Yeah, that's how far we are from the x-axis, right? So we're going to think 45 degrees when we write these. Now, I'm going to go ahead and write them, though, as really what we're finding is sine of 315 degrees. Well, when I say, what is the sine of 315 degrees, what you're really thinking is, okay, what is the sine of 45 degrees according to my chart? Does that make sense? Because 315 is 45 degrees from the x-axis. So what is the sine of 315 if it's equivalent to 45?
Oh.
Square root of 2 over 2. Now, I'm going to ask you another question. What is the cosine of 315 degrees? Or what your brain needs to think is, what is the cosine of the reference angle, 45 degrees? It's the same, square root of 2 over 2, yes? And I'm going to say, what is the tangent of 315 degrees, but what is the tangent of the reference angle? So what's the tangent of 45? 1. Now, it did ask us for 6, didn't it? So, we need to talk cosecant. If the sine of 315 degrees is square root of 2 over 2, what's the cosecant of 315 degrees? Okay, we could say 2 over square root of 2 if we just flip this one. But then when you rationalize 2 over square root of 2, it actually simplifies to be square root of 2. Now, I will say, you guys know how for sine and cosine on your chart originally, I put it as 1 over square root of 2, right? That's the easier one to reciprocal, isn't it? Because reciprocal of 1 over square root of 2 is square root of 2 over 1. Okay, let's see. Cosine of 315, so what about the secant of 315? Square root of 2 again. And what about cotangent of 315? It is 1. The reciprocal of 1 is 1. Now, that was officially step 3. We still officially have a step 4. Technically, these aren't the final answers. We're not quite there. Step 4, which I'm going to kind of put in right here, put the proper signs in front of the answers based on the quadrant. We already talked about this. What quadrant are we in? We are in C, cosine. So, since we're in cosine quadrant, some of these 6 answers are good because they're supposed to be positive. Some of them, though, are supposed to be negative. So what's this C quadrant tell me?
The cosine's positive.
Cosine's positive, and, of course, by default, then secant is positive. What about sine? Sine is actually the negative square root of 2 over 2. If sine is negative, cosecant is negative. We talked about the fact because this angle was in quadrant 4, cosine is positive because that's my cosine quadrant. Cosine's positive, secant's positive. What about tangent? Yeah, everybody other than cosine is negative here. So tangent is negative, so that's actually a -1. And what about cotangent then? it's actually a -1. So when you're in quadrant 1, all 6 answers will always be positive. When you're in any other quadrant, you're going to have 2 positives and 4 negatives. Because you'll always have one main function that's positive, and then it's reciprocal. The other 2 main functions are negative. Those are your 6 answers. Yes?
What does the A stand
All.
for? That's what I thought. I just want to make sure.
Yeah, you're not missing any trig function that begins with A. No, just all. Okay?
Could you imagine if like there's another one? It's like let's say you like miss one day of trade class and you come back and there's like a whole minute. Oh.
It's doable. Okay, guys, let's look at a little bit of example 2. So, example 2, basically we're doing the same thing, except instead of finding all 6, we just want to know 1. And we've got some fancier angles to work with. So, sine of -210. How do you feel about -210? We're going to want to find a coterminal angle. Is that what you're talking about? Yeah.
I know what quadrant.
Yeah.
Oh, that's going to be part of the battle, is knowing what quadrant it's in. And there's a couple different ways we can talk about this one. Are we figured out now?
Yeah.
Okay. Okay, so sine of -210 degrees. First of all, you can try and visualize where -210 is. Thoughts? Quadrant 2? Because, side note here, if we're doing -210, you do what? You have to go down. So you go past 180, right?
That's where I messed up. I went counter.
Yeah. Well, this was negative, which is why I went down, right?
Yeah, that's what.
Okay, so now, that's one way to visualize it. And you could look here and say, okay, that's -210. How far is that from the x-axis? That's doable, and that's fine for some of you. If you are saying, no, I can't do the negative thing. Okay, let's find a coterminal angle. Coterminal is what's another name for -210? How do I find another name for -210? Take -210 and what? Add 360 to it. What is -210 plus 360?
150.
150. Does that make sense?
Yes.
If I say that going this way, it's 150? Right? It's the same angle. 2 different names for the angle. Which one are you more comfortable working with? You don't have to change it to 150. You can succeed here without changing it to 150. But for the rest of us, I changed it to 150. Now, here's what I want to know. Step 1 is I need a reference angle. How far is this angle from the x-axis? 30 degrees. Because right here, if you go with the 150, 180 minus 150 is 30 degrees. If you were a -210 person, you're like, I know, I like this, I can do it. Well, how far is 210 from 180? 30 degrees. So what we're going to do here is when we do this problem, we're trying to find the sine of 30 degrees, but in what quadrant?
2.
Quadrant 2. So that's what you have to think. What is the sine of 30 degrees in quadrant 2? What is the sine of 30 degrees? 1/2. How'd she know that so quick? Her chart. Just in case anyone's saying, what? That was magic. It wasn't magic. It's a chart. What do we know about sine in quadrant 2? It's positive, yes? Because all students take calculus. Sine is positive in quadrant 2, so My answer is positive 1/2.
Let's go.
So if we're asking us to change to tangent, like would we have said it was negative?
Correct. Tangent of negative 210 would have been negative answer. As would cosine of negative 210.
Because our points are in sine.
Because it's in quadrant 2, which is positive for sine. Yeah. Wanted to get through this one. Cosine of 240. We'll talk tomorrow. Maybe we'll see how much you remember at the beginning of class, and I'll make you try that one to get us started. Before we jump into radians, and you guys hate me.